right, we're going to talk about polynomial division, the remainder theorem, and the factor theorem. So we're going to kind of review long division and synthetic division, and then that remainder theorem factor. So the first thing is determine whether x plus 1 and x minus 3 are factors. We're going to do this by long division just to refresh your memory. Okay? So I have x plus 1. This is x cubed plus 2x squared minus 5x minus 6. Now remember, if you're missing any of these, you have to have a placeholder, okay? So x times what is going to give me x cubed? Well, this is x squared. X cubed plus x squared. And now I'm going to subtract these. So that gives me 0 here. This gives me x squared. I'm going to bring down my negative 5x and negative 6. X times what gives me x squared? Well, that's a positive x, so this gives me x squared plus x. I'm going to subtract those. That gives me negative 6x minus 6. X times what gives me negative 6x? Well, that's negative 6. So I get negative 6x minus 6. That's 0. So x plus 1 is a factor of it, right? Because my remainder was 0. So that tells me it's a factor. All right. Now I'm going to go back through and I'm going to test x minus 3. So this one here is a factor. Okay, so now I'm going to test x minus 3 here. So I'm just going to erase this. And I'm going to put in x minus 3. Well, x times what gives me x cubed? Well, that's x squared still. So this gives me x squared minus 3x squared. I'm going to subtract that, so the x cubes go away. 2x squared minus minus, that turns to plus. That gives me 5x squared minus 5x minus 6. X times what gives me 5x squared. That gives me positive 5x. This is 5x squared minus 15x. Subtracting that, that gives me 10x here minus 6. X times what gives me 10x, that's 10. So we have 10x minus 30. I'm subtracting that. That gives me 24. Since my remainder is not 0, this is not a factor. Okay? All right. So the remainder theorem is if a number c is substituted for x in f of x, then the result f of c is the remainder. Okay? So if I were to look at here, so I had a remainder of 24. If I were to plug in 3 into this, I would actually get 24. That's what the remainder theorem says. It's that when I plug in the value, I'm going to get it. So here I have 4x cubed minus 3x squared plus x plus 7 divided by x plus 2. So if you remember synthetic division, what I'm going to do is I'm going to write down all my coefficients here, and I'm going to put what makes this 0. Okay? So now I'm going to drop my first term straight down. This is 4. Multiply, so 2 times 4 is 8. And then I'm going to add these. This is 5. 2 times 5 is 10. That gives me 11. 2 times 11 is 22. Then my remainder is 29. Now, if I went through and I physically plug this in, 4 times 2 cubed minus 3 times 2 squared plus 2 plus 7. Well, this is 8 times 3 is 32. 2 squared is 4 minus 12 plus 2 plus 7 equals 29. So that's what the remainder theorem is stating, is that if I do this division, especially synthetic division, whatever my remainder is, that is the same as if I plugged in that value. Okay? So we got to make sure that we understand that how to use that. Even in long division, we can do that also. So now we're going to determine if 5 is a 0 of g of x equals x to the 4th minus 26x squared plus 25. Now we're going to use synthetic division just because that's what we've been practicing with. We're talking about division here. That does factor. You could probably get it that way also, but we're going to use synthetic. So we're going to go 5. I'm going to pull down my coefficients. So I have 1x to the 4th. Well, how many x cubes do I have? 0, minus 26, 0 x's, and then 25. And so what's going to happen here is I'm going to drop my first one down. 5 times 1 is 5. I'm going to add these together. That gives me 5. 5 times 5 is 25. That gives me negative 1. 5 times negative 1 is negative 5. That gives me negative 5. 5 times negative 5 is negative 25. That gives me 0. My remainder is 0, so 5 is a 0 of it. Okay? The factor theorem for a polynomial f of x, if f of c equals 0, then x minus c is a factor of f of x, right? So if I can find the zeros of this, then I know that x minus c is a 0. So up here, I know that x minus 5 is a factor of x to the 4th minus 26x squared plus 25. All right? So it says let f of x equals x cubed minus 3x squared minus 6x plus 8. We want to factor f of x and solve the equation for f of x equals 0. Okay? So what we're going to do is we're going to look at paring this down a little bit, maybe using synthetic division to get it one less. One of the things, like I put my p's up here, which is the factors of 8. That tells me the factors. My q's are the factors of 1. So if I have q, that gives me plus or minus 1. So p over q is actually plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. So those are my whole factors there. And so what I'm going to do is I'm going to take those, use synthetic division to kind of pare it down, maybe get it into a quadrilateral and see if I can factor it. Okay. I do also notice that my coefficients all add up to 0. So that tells me that 1 is a factor. So if I write down my coefficients here, 1, negative 3, negative 6, 8, I can now plug in 1, and I'm going to get at least that is one factor. So this gives me 1, negative 2, negative 2, negative 8, 0. Okay, so now this is going to be x squared minus 2x minus 8. Well, hopefully you can see that factors. This factors into x minus 4, x plus 2. So now this whole thing is going to factor into x, remember it's opposite side, minus 1, x minus 4, and x plus 2. So now my zeros, so that's what it factors to. My zeros are 1, 4, and negative 2. Okay? So that kind of uses that factor theorem, uses some of the other items we've talked about and kind of gone over. Kind of refresher on long division and synthetic division.